Hello, welcome to my video. And I'm here to show you guys a project I made a few years ago called Mars Liner. So let's take a look. So this is the project. I remember getting the inspiration for this project when I was in sixth grade. Um, I was reading this book called Hello World by Warren Carter Sandy. In it talked about how to use Python and Pygame, and it was basically my first introduction to programming. And in one of the chapters, it talked about how to create a computer simulation for a lunar lander rocket. I remember getting really interested in this and programming it on my own. When I heard about NASA and SpaceX and their future plans to send people to Mars, I thought of making a project that would basically simulate what an astronaut inside a rocket going to Mars, what they would see and what they would basically control, their control panel. So yeah, let's take a closer look at this. Okay, so here's a closer look at the Mars liner. So first let's turn it on. Just gotta do some pre-checks just to make sure the screen works and all the lights work. And this displays Mars Lander, Bolonic Suit 2023. The next part is a menu, so you can select if you want to play missions or free play. Missions is basically where you start off at a specified height, and then free play is where you start off on the ground and then you can just do whatever you want. This button can select, so which option you're currently choosing, and then this button is to just select the option. So I'm going to start off with missions for now. Alright, so we immediately jump into the action. Let me just kind of give an explanation for what all these are. This is basically the height display. So how many meters off the ground the rocket currently is. This is displaying the velocity in meters per second. This is acceleration in meters per second squared. And then this is currently displaying the fuel. If we change this switch right here, we can change what this displays. So instead of displaying fuel, it now displays the engine temperature. This potentiometer right here changes the thrust that I'm applying to the rocket. So kind of my throttle, kind of. So as you see, if I turn this, it changes the acceleration of the rocket, which also changes the velocity and also the height. This actually, what this does is you can select how many boosters you want to use. So right now it's in down position, which means right now with this at max, we have 9 meters per second squared of acceleration. If I turn to this, then you see it immediately lowers to 2.78. There's also a row of LEDs right here. So most of these don't really have any purpose for now because I just don't have any stuff added to them. But the first light is just kind of like a light to basically say the rocket's working and kind of just for fun, not really any purpose, but to make just to look cool, yeah. Oh wait, hold up. I'm currently going negative 100 meters per second. That's not good. But, oh, it just crashed. Restart. No, wait, no, come back. No. What? What? Alright, this time, I'm actually gonna win this. Yes! You've successfully landed on the surface of Mars! Okay, so the schematic and PCB design was made in Eagle PCB. Well, here you can see the schematic. Let me zoom in. So let's look at this part first. So this part is the power control. So we have the power connector right here, and this is coming in to a 7805, which is a 5-volt voltage regulator. This is an LED to display the power, and so this is the entire part is the power section. Right here in the middle is the microcontroller I used, which was basically derived from the AT89C52 microcontroller from Atmel, or the 8051 microcontroller from Intel. But this is another version made from SDC, which is another company that basically makes like a newer version of the A051, but with more capabilities and components. So this is basically the minimal system for the A051. We have the clock, the reset, which there's no button for it, but it just has a circuit. And then right here, the rest of this is all for the 7-segment displays. So right here is all the transistors that drive the 7-segment displays. Right here is the LEDs. Right here is the buttons, switches, connectors. These are connectors, and this is the LCD screen. Right here we have 8 connectors for potentiometers that we can connect to it. But right now I only have 1 for the thrust, but I could add more. These are connectors that are directly connected to these pins of the microcontroller. And right here, these 4 are the 7-segment display connectors. This is the serial port. So for 7-segment displays, you have to loop through them and basically really blink them really fast to seem like they're all on, but actually only one is on at a time. And so this way you can save pins. In the same way, right here in my circuit, I only have 8 pins for each of the 7-segment displays. And the clocking, where the pulsing of each, is done by 2 4017 decade counters. So all it takes is a clock input right here, which clocks the 4017, and it just basically goes through all of these, which is each of these is connected to a transistor, which is right here connected to the 7-segment displays or the LEDs. Okay guys, I think that's it for this video. The files for the PCB and the models for the panel and the sides are all linked in the description with my GitHub. And please like and subscribe, and see you guys for the next video.